Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called The Pairrow's Surveyors by Andrew Sarkis. And here are the rules. It's chaos construction, where we need to divide the grid into 9 orthogonally connected regions and fill the grid with the digits 1 through 9 with no repeats in any row, column, or region. Now, how do you construct orthogonally connected regions? Well, that means for a region, you need to, actually, this is too small. 1, 2, 3, 4, 5, 6, 7, 8. You could have something like this, 9. And this would be a valid orthogonally connected region, because valid orthogonally connected region means you can go from any cell in that orthogonally connected region to any other cell in that orthogonally connected region just by going through edges, all while staying within the region. So for example, to get from here to here, you would just go along this line, going through this edges here. And you could do that for any pair of cells in the region. What would not be a valid orthogonally connected region is something like this, right? Because this cell, to get to any other cell in the region, would have to go through a corner or would have to go through an edge but exit outside of the region. And that's not allowed. You couldn't do something like you couldn't also do something like, I don't know, this, right? This is not valid too. Because even though these two can go to each other by going through edges, they can't go to any of the other cells in the region by going through edges while staying within the region. And that's an example of how chaos construction and orthogonally connected regions work. For each region, its first cell is the leftmost cell in its topmost row, and its last cell is the rightmost cell in the bottommost row. So this would be the first cell for this region because it's the leftmost for the top row. And this would be the last cell because it's the rightmost cell in the bottommost row. So I guess that's going to be important. Probably with the Pairrows would be my guess. And we have Pairrows, where a cell containing a pair of arrows indicates the location of the first and last cells in a different region. The digit in the arrowed cell is the distance to one of the cells in the one of the indicated directions. That cell will contain a digit which is the distance to the other cell in the other indicated direction. And these two distances must be distinct. I believe they cannot be the same, I would just think. Or they must be unique. That would make more distinct is kind of ambiguous, but I think what the setter is basically trying to say is that they have to be different, essentially, right? So, how does this work? The digit in the arrowed cells, so it points to a first cell and a last cell, and it points to both of them. The first cell, one of the cells, the digit in the arrow cell is the distance to one of the cells in one of the directions, right? So, for example, you could have something like 3 here, and therefore it would be pointing to one of these. But obviously, there are some things it could be, but basically, say it was pointing to the first cell here. That means this cell is the first cell of a region. And then this could be something like 2 or something like that. And that would say that in this direction, you have to go 2 steps here, and that would be pointing to the last cell. So you could have something like this be a region. 2, 3, 4, that's too few. You could have something like this be the region, right? And this would be valid, right? Because this 3 is pointing to one of the either the first or the last cell, and the digit in it basically tells you how far to go for the first or the last cell. And then the cell that it's being pointed to, also has a digit, and that digit indicates the distance to the other cell in the other indicated direction. And these digits must be different or distinct. For example, if the pair of arrows in row 2, column 9, so they're using that one, points to the some region's first cell in row 2, column 6, and to its... Okay, so let's remove that. So right now we're looking at this cell. It points to a first cell somewhere along this row, and then a last cell somewhere along this column. So say it was pointing to row 2, column 6. So this is part of that region. And row 4, column 9. So somewhere in... that's this part of the region. So this is the first cell of the region, of that region, and this is the last cell of that region. Then either row 2, column 9 is a 2, and then row 4, column 9 is a 3, right? Because this would say, okay, the last cell, specifically, in row 2, column 9, must be 2 away from the cell in this direction. So that's 2 away. And then since row 4, column 9 is a 3, that's saying, and it's pointed to by this Pairrows, that means it must go 3 in this direction for the first cell. Or row 2, column 9 could be a 3, and then row 2, column 6 would be a 2. So this is saying to get to the first cell, you have to go 3 in this direction, which you do, 1, 2, 3. And then since this is a 2, that means to point to the last cell in that region, it must be 1, 2 from the Pairrows. And no two arrow pairs point to the same region. So all of these distinctly define the first and last cells of a different region, right? They can't point to the same region. And I think there's 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these point to all the first and last cells of a region. Okay. So that's how the Pairrows work. We have quadruples, where a circle on the vertex in the center of a 2x2 is a quadruple clue. Any digit in the circle, any digits in the circle must appear in one of the 4 surrounding cells. So this is a typical quad circle clue. Therefore, okay, also, in this puzzle, the 4 surrounding cells always belong to the same region. And all 2x2s belonging to a single region have a quadruple clue. Okay, so there is a negative constraint here. So basically, anytime you have a 2x2 area, so anytime you have a quadruple clue, the digit in the circle must appear at least once in the 4 surrounding cells around that circle. Well, in this puzzle specifically, so for example, around this quad circle, there must be a 2. An additional thing about the quad clues is that in this puzzle, the 4 surrounding cells always belong to the same region. And any 2x2s belonging to a single region have a quadruple clue. So that means if you have... So there must be a 2 around here, right? And so this has to have a 2. This has to be all the same region, if that's the case. And if So these are 2 by 2. That means they're the same region. This is a 2 by 2, which means it's the same region. This is 2 by... Okay, that tells you a decent amount there. That's interesting. If you do not have a circle on a vertex, which is the quadruple, then it cannot all... That 2 by 2 space cannot be in the same region for all 4 cells. But because all 2 by 2s belonging to a single region already have the quadruple clue, right? So keep that in mind. There is a negative constraint there. We have cave, where digits encircled cells count the number of cells seen, including the circled cell itself, in the row and column combined, where region borders block the view. So that means if, say this was a 7, that means this cell would see 7 cells in the same region. So it could be something like this. And region borders block view, right? So this would see 7 cells that are part of the same region. Obviously, there would be 2 more somewhere that this doesn't see. But that's what the digits in circled cells mean, right? So this would be a valid circle cell because it sees 7 cells in its own region. And box borders block view. So if we try to have, say, this being 5, or actually, let's just say that's 7, right? Say we did have that as 7 still. Actually, that's hard to do. Let's do 6. This, well, okay, that's gonna be... maybe we could do this. This would not see 6 cells because region borders block view, right? So even though there are 6 cells in the same row and column as this cell, this is not valid because it only sees 5 because this cell is being blocked by a region border. And that's what the circles in a cell mean. And we have the negative constraint for these cells too, because all possible cave clues are given. So there is a constraint here where if this basically, say we had, well, say we have a 2 here. This cannot just see 2 cells in its region, right? So it could not be something like this. Would not be a valid region because, or that wouldn't be a valid region because it's too few. But say this was the region. You could not have a 2 there because there's no circle in that cell. And this does only see 2 cells in its region. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. All of these are the same region. Yes, they're all the same region. So is this, because it has a quad circle there. So does this. We'll mark that as light. We'll mark this as medium. These are just basically what I feel. Orange. This has to be the same region. This is the same region, and this is the same region. So we have 8 cells in the same region there. This has to be a different region, and we're going to mark this as red. This must be a different region than this and this, because we already have 8 cells in that region. So let's mark the boundaries. We have that, definitely, and that. Okay. Part of the question, though, for this is... So this can go 1 up here, 1 up here. So where is the first cell and last cell of these regions, of these cells? This can only gain 1 cell. So either this is the first and this is the last, or you can change one of them. So the question is this pointed to by anything? So you can point to, okay, so then the Pairrows that match this region, since every Pairrows points to a different region, the Pairrows that match is either this cell or this cell here, right? Because this cell must be pointed at, or this cell must be pointed at, or both, right? And this must be, and you can only point from, like, you can't point to any cell that is above this region or this row, right? Because this region can only go up to here at most. So, therefore, that rules this out, because it will always point to something that's going to be farther away than that. This rules that out. This is too far away. It always points to something here, but that can't reach, right? Because you can only go one here. This points to something above. This points to something above. This points to something above this possible one. So, and this one does not point to either of these, and it must point to either of these. So this one must either go this one and that way, or it could go here. So the yellow can only be going to one of these two, if it's this one, and then points to that. Or the yellow could be pointing at that one and then pointing to one of these three cells. So yellow could go down to there. So those are the possibilities. We know that all of these are yellow. These could be different colors. So let's make that orange. We'll give blue a possibility going that way. Blue. Okay, so blue has to have... Can blue go all the way over here? It's potentially possible. Okay, so how does blue... So where can blue's arrows be? Not this one, because this has to be... This is definitely being pointed at. So that's pointed at by this cell, but that's too far to go, though, that way. Right? This is 1, 2, 3, 4, 5, 6, 7, 8, and 9. It can't reach that row to have the other cell be, the first cell be there. So this is definitely a last cell here. It cannot be reached by that. That's not pointing it there. It can't be reached by that. It cannot be, it could be reached by here. But the problem is it would have to go all the way down here. It would have to go down here, and this would have to be a first cell. But then this is guaranteed to be at least higher than this cell here. So you cannot go 7 cells here and then 2 cells here, because this is the bottommost row. It's not the topmost row. So that's not possible to be the first cell. So this cannot point to it. This can't point to it because it's too high. It doesn't point to this one. This is too high. Also, this is too high. So this must be pointing to this one. That means yellow must be pointing to the yellow region. So yellow cannot go there. So yellow has to be one of these two. So this points to here. So it's either 2 away or 3 away. Right? Because it can't go anywhere else. And then this is 4 away. So this is basically 2, 3, or 4 there. This must point to here. And then the blue has to be, cannot... Can it be part of this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No. So it has to be then all the way up here. Or, no, it's this one. Sorry. 1, 2, 3, 4, 5, 6, 7. No, sorry. 1, 2... Wait, but the problem is these have to be different numbers. 1, 2, 3, 4, 1. Oh. It can't, so okay. These have to be different numbers. So it cannot be pointing to this. Therefore, it must be pointing to here. right? So this is pointing to here because again, these can't be different. These can't be the same number. 1, 2, 3, 4, 5, 6 would be the same number as 1, 2, 3, 4, 5, 6. So can I just go up that way? So it must be 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's done as a region. And so this must be 1 or 6 here. If this is 1, then this is 6. If this is 6, then this has to be 1, but this does not see only 1 cells, so this must be pointing here, and then the 6 is saying that this has to be that way. So this must be 1, and this must be 6. This sees 1, 2, 3, 4, 5, 6, 7 cells, so that's 7 there. Okay, so this one points to here and one of these two. We know there has to be a 1 surrounding this. There has to be a 2 surrounding this. This sees more than 2, so therefore there must be a 2 going in one of those 3. There has to be an 8 surrounding here. Which is the one that's pointing to this cell? It has to be this one, right? That means, so whatever region's here, it cannot end up here. These can't be part of the same region. So, okay, this cell has to be the first of some region, period. So if this is a different region than the light region, then something has to be pointing to that cell too. But I don't think anything's pointing to that, right? This is too low, this is too low, this is too low, this is pointing that way, not at there. This is pointing that way, not there. This is pointing too low. So this is pointing to this cell here, and it must be part of this region then. Because this is not part of a first cell, and if it were part of a different region, this would be then a first cell guaranteed. So this one's pointing to yellow, this one's pointing to blue. We don't know what that is pointing to. Probably green would be my guess. Could be red. Yeah, so this is light, so this is pointing to 1. This cannot be the same part of this medium region because this is already 5, that would be 6, and this would add 4 to it, which would be 10. So this must end essentially either here or here. It's too many cells to go to there. 1, 2, 3, 4, 5, 6, 7, which plus 5 adds up to 12. So it has to go to here. So it could do, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's too much. So this has to be light then. So we have 1, 2, 3, 4, 5, 6, 7. And then you have 2 more. And they have to connect either one of these two. This does not see 1, 2, or 3, guaranteed. It sees 4, though, completely. So this is at least 4, and it could be 2 more, 5 or 6. Okay. So this one's pointing to light. I don't know how to signify that. This one's pointing to yellow. This one's pointing to blue. I'm not sure how to signify that. Maybe we can do that. It's as hard to see, but anyways. Light, that's light. So we have guaranteed that these are pointing to those. This is 2, 3, or 4. Okay, so this is 4 here. Where can the green's first cell be? It can obviously be here, It could be either of those two. It could be any of these. It can't be part of light because, again, this would be 5, and then if we try to connect that, 6, 7, 8, and 9, 10. That would be too large. And we still need that for the lights. So green's first cell, it cannot go all the way here and then up. So this has to be 1 or 1, 2, 3. So this is 1 or 3 here. I think it said, yeah, it's a different region for the Pairrows, right? Indicates the location in a different region. Okay, so then this is not part of that region. So this can, okay, well, first of all, the lowest most cell is this, at least. So the first cell of the green region, again, cannot go all the way here and then up. Actually, it could. That's 4 and then 9. So the first cell has to be one of these 5 or this one. So that is possible. But it would need to be pointed at, it would have, if it goes this way, it has to, there has to be something that points at that cell. Well, the only arrow right now that points to that cell is here. None of that's pointed to, none of that's pointed to, none of that's pointed to. This one arrow, the rightmost is here. 2, 3, 4, 5, 6, 7. So that's possible. So say this one was the one that's pointing to green. We'd have 1, 2, 3, 4, 5, 6, 7, 8, and 9. But the problem if that is that this would basically have to be all red. And there would have to be a quad circle surrounding that. And that's not possible. So this cannot be pointing at the green then. Right? Because it would have to be specifically those 9 to fulfill that. And that's not going to work. So this cannot be... So that means this has to be a different region, and it cannot be part of green. Interesting. So maybe we should make this pink, and we'll make this other one red. Because this has to be, one of these two has to be a different region, because otherwise there would be a quad circle around it. So we have this guaranteed, because it has to get out. I guess it could be green. But is there something pointing to there? The answer to that is no. So you could have green if it does that. But the problem with that is nothing's pointing to these two cells specifically, right? This and this. So say we tried to have that. This points to there, but it'd have to point to there. And this doesn't match, right? So this one doesn't work. This one obviously is not pointing to green. This is not pointing to green. This is pointing to light already. This points to something up here. So this doesn't work. So therefore, that's why this has to be a different region. And this could be red or it could be pink. We're not sure which. So then this has to be a different region here. The red has to exit out somewhere, so it has to go that way. 1, 2, 3, 4, 5, 6, 7, possibly 8. We have one more, and the pink has to go. Cannot be part of yellow. Pink has to go this way, which means red has to go that way. We have 1, 2, 3, 4, 5, 6. That means this has to go there. 7. Red can just stop here if this is all red. But how does this work then? Because these are the same distance away. 1, 2, 3, 4, 5, 6, 7, 8. And if this is red, This is the only one that points to both of them. Green also has to be something, right? So this is 9. So it blocks red. But then this has to... That doesn't work. Because this is 1, 2, 3, 4 away. This is 1, 2, 3, 4 away. Unless distinct is not unique. But... 5, 6, 7. Pink could go that way. These could all be light. Green has to go this way because that's guaranteed. This is light or medium. Shoot. But the problem then is this doesn't match anything. So green has to go up here because it has to match this. So this is not light. This is definitely green that way. It could go green 2 more that way then. So that's possibly green. Pink could obviously go to any of these. Light has 2 more here or here. The problem, yeah, this is still problematic because this goes 4 that way and 4 this way. This has to be red and green, though. That's the problem. 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? And it's blocked by there. Oh, pink could go this way. So it doesn't... Okay. Right. Okay. Right. Yeah. Okay, that works. So this does have to go red here. This green does have to go out here. So since green has to go out, therefore this pink... This cannot be red because it can't be pointing to both these and this. So this must be pink. This must be pointing to the red region. And pink has to go this way. So this is pink. And then red has to go out this way to extend. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And that works. Okay. So then this is a boundary. Pink goes here. This is then yellow. So this is yellow done as a region because we have 9 cells. So this cell points to here and here. This is 1, 2, 3, 4 that way. 1, 2, 3, 4, 5 that way. So this is 4 or 5 here. Red is done as a region also. Pink goes 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's done as a region. So again, to point to... This is the bottommost row. So this must be pointed at. And it cannot be pointed at here or here or here. So this must be pointed at by this. So this is the green cell. So that means green has to go up to here. It cannot get through here, so therefore it must be green here. So we have 2 more greens. It could be here, or it could be this way. And this is going to be the last cell. These could be light and light. This is medium, possibly. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So these two cells must be pointed at, and I think it's pointed by that. So this is the pink region. So we have yellow, this is pointing to blue, this is pointing to red. That's pointing to red. This is pointing to light. We have this pointing to green, which is that one and that one. That means we need to point to orange, medium, gray, and dark. So medium gray has to be either here or one of these, or this one. So one of these two is the first cell for medium. I don't think this is pointed to by anything. No, there. So we have these three. That means this must be the one that's pointing to it. So this must be medium here. So this is medium. And it must go down to here, to this level. Well, it can't reach all the way down there. That's too many. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it can't reach there. It has to reach one of these three. So one of these three is medium. We're not sure which. This cannot be both greens. If this is both green, actually it could be. No, it can't be, because this must be pointing to light. This is the rightmost cell. So this is guaranteed to be that way. And it cannot go down. So this is border. So it must have one of these two. It could do something like that funky. That's possible. So this must go, this has to be gray this way. So we have 1, 2, 3, 4, 5, 6, 7. But if we go 8 and 9 here, one of these has to be light gray. And that's because 1, 2, 3, 4, 5, 6, 7, 8, 9. So green has to go to here. So this has to be green, not medium. So this is definitely green here. And then we could go green there if this is 2. Okay, so then boundary-wise, we know this is boundary, this is boundary. This is obviously boundary. This points to medium gray. So then we need to point to orange and point to dark. Okay, what are the numbers? This is 4 or 5. This is pointed to pink, which is 1, 2, 3, 4, 5, 6 away. This 1 means this cannot be pointing to this one first. So it must be pointing to this one, which is 2 away. So this is 2, and this must be 6. Right? Pointing to 2 here. Then 1, 2, 3, 4, 5, 6 as the last. This is 1 or 3. This is 3 away. And then 1, 2, 3, 4 or 5. 3, 4. Okay, wait, no, it has to be that one. Because that one is definitely the border. Or sorry, the last cell of. So it's basically the lowest. The rightmost of the lowest cell. So this is 3 and 5. We have 3 and 5 there. Okay. This points to not... So this has to be a cell. So 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5, 6 or 7. So this is 5, 6, or 7 there. We don't know which one it points to. This one sees at least 3 cells. So that's at least 3. Oh, this sees 1, 2, 3, 4 cells. So this is 4. It's pointing 4 that way. So it's 1, 2, 3, 4. So that's 3 then the other way. So then that's 1, 2, 3. Okay. There must be a 2 around this one. This sees 1, 2, 3, 4, 5 at most. So 4 or 5. No 6. Can this ever be orange? We have 1, 2, 3, 4, 5, 6, 7, 8. Yes. It could also be dark. If this were part of orange, the problem is that would block this from being a different region. So this must be part of dark. Right? Because the Pairrows point to a different region. So therefore this must be this must be signaling the orange region. And this must be signaling the dark region then. Which means, okay, so the dark to get over there, so this is definitely dark. So this is boundary here. Because it must be pointing to there, and then to get there, it has to go that way. That's 1, 2, 3, 4, 5, 6, 7, 8. We have one more axis to dark. So these could be dark, and these could be dark. It cannot go down here. So this has to be orange here. So this is orange going that way. So this must be dark here. So this is 5 or 7 being pointed at. And this is boundary. We have 1, 2, 3, 4, 5, 6, 7. We have access to 2 more as medium. So any of these could be medium, any of these could be orange. 1, 2, 3, 4, 5, 6, 7, 8. Orange has to go up to here. So orange must be one of these two. Orange does point to here. Okay. Huh. So this is either 1 or 2 away that way. This is 1, 2, 3, 4, 5 away. So this is 5. 1, 2, or 5. Okay. We have 1, 2, 3, 4, 5, 6, 7. So it must be 2 going up or 2 going up. If it's 2 going up, you have 1, 2. You could go dark down here, and this would be medium. Or if it's 2 going up, oh, it cannot be 2 going up here, because then you'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 darks. So this must be 2 orange going this way. So this is 2 orange, which means these can't be orange. This is medium. This dark has to go out here. So this is dark. So that's done as a region. So this is 1 or 5. We have 1, 2, 3, 4, 5, 6, 7, 8. So yeah, we have some combination of digits here. You could do something like that still. Okay. Now we have to do, okay, so this sees 1, 2, 3, 4, 5, 6, 7. So that's 7 there. We have to use the negative constraint for the caves now. We know 2 was one of these 4. Okay. So we know what each cell does see. Obviously this can't, so we have 7 here, 7 here. We need a 7 for the dark. It has to be one of these 2. 7 cannot be here. 7 has to be one of these cells. So if we do have 5 there, that does match us 7 there. If we go 7 here, this would have to be 5. One, two, three, four, 5. Hmm. Okay. Do we have anywhere with a lot of stuff? Not really. Let's do column 3. We have 3, 5, 6, 7, 8, and 9. Okay. This sees 4 cells, so that's fine. This cannot have a 6 in it because we have a 6 in that region. This can't be 6 because of 6 in the row. No 7 here because of 7 in the row. Oh, what is this? This points to green, so it's 1, 2, 3 away, and then 4, so 3 and 4. This sees 4 or 5. This sees 3. This sees 2. This sees 5. We see 4 there. 4 here. So red regions. Ugh, it's just too many. Row 8. Let's do row 8. This sees 3, right? 1, 2, 3. So this cannot be 3. This, we don't even know. It's, yeah, it could be many. This could be 4. So that's possible. Row 8. 1, 2, 5, 7, 8, 9. 1, 2, 5, 7, 8, 9. And this can't be 7 because of 7 in the region. No 1 here because this has to have a 1 surrounding this quad. This can't be 1 because of 1 in the region. This could be 1. So this sees 4 cells. This sees 3. This sees 4. This sees 1, 2, 3, 4, 5, 6. This sees 3. This sees 3. So nothing there either. Remaining pink cells. 1, no 1. 2, 3. 2, 3, 5, 7, 8, 9. This sees 4 cells. This sees 4 cells. This sees 3, so this cannot be 3 here. This sees 3, so that cannot be 3 here. Aha! 3 can't be here. Where's 3 in the pink region? It has to be here. Because this does not have a cave circle, so it cannot see 3 cells. Neither can this. So 3 has to be one of those 3. 3 for blue cannot be here because, oh wait, that sees 7. Never mind. So 3 has to be one of these 4 in blue. So this cannot be 3 here. We can't have 3 here. So 3 could be in red, has to be one of these 3. Okay. Huh. Okay, so if this points 4 that way, this could be 5. If this points 5 that way, then this could be 4. That actually works both ways. Great. Hmm. Brr. Oh boy. I think I just have to try them. We have 6 here and 6 here. So the 6 in the medium gray region has to be here. Right, 6 in column 9 has to be in the dark or orange. So does 6 in the orange region. Has to be in 9 or 8. 6 cannot be any of these, so therefore 6 has to be here in the red region, which eliminates 6 in the rest of the red region. The 6s in rows columns 1 through 3 has to be in red, green, and light. That means, right, so one of these is a 6. And one of these 4 is a 6 also. Interesting. That means we also have 1 here. Let's do yellow region. We have 1, 2, 4, 5, 6, 7, 8, 9. Okay. And this can't be 1 or 6. No 1 or 6 there. How many cells do this see? 1, 2, 3, 4. So this can't be 4. This sees 4, so that can't be 4. Oh, so we have 1, 4, and 6 here. This sees 5. So 5 can't be here. This sees 4. So 4 can't be there. This sees 5. So 5 can't be there. This sees 6. 1, 2, 3, 4, 5, 6. So 6 can't be there. This sees... Okay, so we have 4, 5. This sees 4, 5, 5, 6, 6, 4, and 4. Okay. So 1, 4, and 6 are here. Interesting. This sees 6. 1, 2, 3, 4, 5, 6. So this cannot be a 6 here. This could see 6, but we don't know. This sees 5, so 6 could be there. This sees 2. So this has a 3 here. Okay, so what are the digits here? These two have to be a 6 and whatever digit is here. Oh, 1 can't be any of these, so this has to be a 1 here. Okay. So this is 1 definitely here, which means this can't be 1. This digit here must match this, but not a 1. So this is 6, and it's 2, 5, 8, or 9 as possibilities. Okay. 1 has to be one of these 3. 4 is one of these 3. can't. Okay, so if this is 5, we have 1, 2, 3, 4, 5. This can't be 4. So this cannot be 5. Therefore, this must be 4, pointing at this one, which makes that a 5 to have that point there. So this cannot be 5 anymore in the red region. So there we go. This can't be 5, so this must be pointing at 7, which is pointing there. So 1, 2, 3, 4, 5, 6, 7, which forces this to then be 5, because 5 has to be pointing 5 that way. That eliminates 5 and 7 in the rest of the row. This 5 eliminates 5 here. Also eliminates 5 here, 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 and here. Okay. 7 eliminates 7 in the rest of the red region and the column. Okay. That means 5 cannot be any of these. 5 is one of these 4. We also have 5 as one of these 4, which eliminates 5 in the rest of... Yeah, right. Where is 5 in row 9? It has to be one of these, so this cannot be 5 here. 5 eliminates 5 here, so that's 1, which means this is pointing to here, so then this is 1, 2, 3, 4, 5 away, so this must be 5. Okay, so 5 cannot be here or here. Remaining digits of red. We have 1, 2, 3, 4. No 6 because 6 is here. 8 and 9. This can't be 3 because one of these is 3. So 1, 2, 3, 4, 8, and 9. Okay, this sees 2 cells, so this cannot be 2. This sees 6 cells, so that's fine. This sees 4 cells, so it cannot be 4. So 4 is one of these 2. Okay. Remaining cells of column. Oh. Well, 6 cannot be any of these because it sees 6 cells. So 6 in this region has to be one of these 4. And it cannot be one of these 2 because we know in columns 8 and 9, the 6s have to be in the orange and the dark region. So this is 6, which means that can't be 6 in the rest of the row. Six could be here, or it could be any of these. 6 cannot be here because that sees 6 orange cells. 6 could be here. It can't be here because of 6 in the row. Can't be here because it sees 6 cells here, so one of these 2 is a 6, which eliminates 6 in the rest of that row. But we already were eliminating 6 from the rest of that row anyways. So this can't be 6 here. What else do we have? We have a guaranteed 5 here. So pointing to 5. So if this is 3, that would 4. Okay. So if this is 3, obviously you can't have 3 in the row. If this is 4, that doesn't make any sense. So if this is 3, that means it's pointing to there, so this must be 4. If this is 4 pointing to there, that means this must be 3. So one of these, okay, yeah. One of these is 3, right? If this is 3, obviously there cannot be a 3 in another row. If this is 4, it's pointing to there, and that's saying this must be 3 going that way. So one of these 2 is guaranteed to be a 3, which means this cannot be 3 here. Okay. Maybe same with this, 3 and 5. If this is 5, that forces... Okay, yeah, if this is 5, that forces this to be a 3, because that would have to say you have to go 3 from this on this way. If this is 3, obviously it's 3, and this can't be 3, so this must be 1 then. So this is 1, which forces 3 to be there, which means this can't be 3. It's 4, so it's pointing to that, which means this must be 3. So then, because of that, 3 eliminates 3 here, so it's 5. So that's saying we have to go 5 away, which means this must be 3 there. And it's pointing that way. This is 5. 5 cannot be any of these. 5 could be one of these 3 for the light region. Okay. Remaining green digits, we have 2, 4, 6, 7, 8, 9. Okay. Well, the problem, though, is we don't have certainty here. That's not going to be helpful. Okay. Actually, I think all the arrows are done, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, they're done. Okay, so let's make sure they're all pointing to the correct thing. This is pointing to there, 5, which makes that 3. That's fine. This is pointing 4 away to there, which says you have to go 3 that way. That's fine. This is pointing 1, which means you have to go 5 this way. That's fine. So that's 5. Pointing 2 that way, which says you have to go 6 this way, which is fine. Pointing to 1, which says you have to go 3 that way, which is... Oh, that eliminates 3 in the rest of the light region. This can't be 3 anymore because of 3 in the column. Where is a 3 in row 2? Cannot be either of these cells because we're guaranteed a 3 here. This is 7. Can't be 3 in the green or light regions because we already have a 3, so this must be 3 here, which means this can't be 3 here, and a 3 here. Where's the 3 now in column 3? It has to be here because there's no other place for it. So this cannot be 3 here. 3 in column 4 has to be either here or here. Oh wait, cannot be in medium either. So 3 in column 4 can't be in medium or light, can't be in red or pink, so it has to be in blue. So this is 3. None of these could be 3 here. Obviously this can't be 3 here. So where's a 3 in orange? Cannot be here, 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 or here, so 3 has to be here in orange. And we have 8 3s. We know where the last 3 has to be. It has to be here, which means 6. That's 3 in the corner. We celebrate because we know we're close to solving it. 6 for the dark region. Cannot be any of these because it matches how many cells it sees. So that means 6 has to be here, which means this can't be 6. This is 6 there. 1 here eliminates 1 here. So where's the 1 in the blue region? It cannot be here because of 1 in the row, so it has to be here. So this is 1, which means where is 1 in the orange region? Can't be here, so this must be a 1-2 pair. 1 eliminates 1 here, so this is 2, which makes this 1, which eliminates 1. Oh yeah, this can't be 1 anyways. So one of these 2 is a 1 here, which means this can't be 1. The light needs access to a 1, and this can't be 1, so 1 has to be one of these 2. And this can't be 1, so therefore light needs a 1, access to a 1, and this can't be 1. None of these could be 1, and this can't be 1. So this must be light in 1. Therefore, green, well, we don't know. We still don't know. This sees 5 cells now in the region. So this is 5. Eliminates 5 in the rest of the column. Where's 5 then? We have a 2, 8, 9 triplet in the pink region, which eliminates 2, 8, 9 in the rest of the region. This can't be 2, 8, 9, and this can't be 2, 8, 9, it's 7. This can't be 2, 7, 8, 9, so it's 5. That eliminates 5 and 7 in the rest of the row. No 7 there, no 5 there. 5 has to be one of these two. We have a 2, 8, and 9 triplet in row 8, which eliminates 2, 8, 9 in the rest of that row. So this is a 5, 7 pair, which eliminates 5, 7 in the rest of that region. Okay. 7 eliminates 7 in the rest of the column. Rest of okay, this 7 eliminates 7 in the rest of the column. This remaining digit in column 2 has to be 2, 4, 6, 8, 9. Cannot be 4 because of 4 in the row. So this is guaranteed to have a 4 here, which eliminates 4 in the rest of the green region. So this can't be 4, this can't be 4. How many 1s do we have? Remaining cells in orange have to be 4, 8, and 9. That eliminates 4, 8, and 9 the rest of the column. So this can't be 4, 8, and 9. It's 2. So this is 2. That forces this to be 8 because 8 needs to be surrounding this quad. That leaves... so this cannot be 2 and cannot be 9 anymore. So it's 6, 8 as a pair. That forces this to be 5 and 9. Oops. 6 and 8 eliminates 6 and 8 in the rest of the red region. So this is not 8. We are guaranteed 1 here and 2 here. So that eliminates 1 and 2 in the rest of the column. So this can't be 1 or 2. Can't be 3. Could be 4, 7, 8, and 9 as possibilities. Okay. This can't be 2 because of 2 in the row. Remaining digits in row 4 are 4, 6, 8, and 9. This can't be 6. This can't be 6. We are guaranteed a 6 in the green region in row 4, which eliminates 6 in the rest of the green region. So no 6 here, no 6 here, no 6 here. Where is the 6 in column 1 then? Can't be in the green, can't be here. So it must be in the red region, and it can only be here. So this is 6, this is 8, which eliminates 6 and 8 in the rest of the column. Or 8 in the rest of the column. We have a... Yeah, I already knew that. That's 8. Okay, anyways. We can remove the outer stuff here. This 1 eliminates 1 from being here. So that means we have a guaranteed 1 going this way. 2 eliminates 2 from these cells. 4 eliminates 4 from being here. Remaining digits in column 6 are 5 through 9. This can't be 6 because of 6's in the box, in the region. This can't be 5 because of 5's in the row. So we have a 7, 8, 9, 6, 7, 8, 9, well, a 7, 8, 9 triplet in column 7. So this can't be 6, 8, or 9, it's 6. This can't be 6, 7, 8, and 9, it's 5. So that means 6 cannot be here. Okay, 4 eliminates 4 from being here, it's 8 or 9. 8 eliminates 8 from being here, so that means the rest of the dark region here is 2, 4, and 9. This can't be 2, so this is 4, 9 as a pair, which eliminates 4 and 9 here. So that's 2 there, which eliminates 2 in the rest of the row. So this can't be 2. We have a 4, 9 pair in row 5, which eliminates 4 and 9 in the rest of the row. This can't be 9, it's 8. This can't be 8 or 9, it's 7. That eliminates 7 here and 7 there. 4, 9 pair eliminates 4, 9 in the rest of the dark region. So this is 7, 8 as a pair, which eliminates 7, 8 in the rest of the column. This can't be 8, it's 9, which eliminates 9 in the rest of the row. This 8 eliminates 8 in the rest of the region. So this is 2. This becomes a 1, 4 pair here. 2 eliminates 2 here. This is 8, 9 as a pair, which eliminates 8 and 9 in the rest of the column. So this is 5, this is 9. 5 eliminates 5 here, so it's 7 and 5. That means the last remaining digit in column 5 is a 1. Last remaining digits in column 6 is 2, 6, and 7. Again, 6 cannot be here. So we have 2, 6, 7 guaranteed in medium. That leaves just 8 and 9. So this is 8 and 9. We have an 8, 9 pair in row 1, which eliminates 8 and 9 in the rest of the row. This can't be 8 or 9. It's 4. This can't be 8 or 9. It's 7, which makes this 8. 7 eliminates 7 here, so it's 2, which eliminates 2 in the rest of the column. So this is 6, 7 as a pair. 4 eliminates 4 here. We have 1, 2, and 9 triplets in the red region, so this can't be 9. This is 4. That eliminates 4 here, so that's 9, which means where's 4 in column? Well, 9 eliminates 9 here, so it's 2 and 9. That eliminates 9 here, so it's 8. This can't be 8 anymore because of the region. This can't be 9 because of the region, so this is 6. This is 4. 4 eliminate 2 and 9 eliminates 2 and 9 here, so it's 6, which makes this 7, which makes that 6. This can't be 6 or 8, it's 9. This can't be 9, it's 8, which forces this to be 9. This can't be 2 or 9, it's 8, which forces that to be 9, which forces that to be 8. 4 eliminates 4 here, so it's 9 and 4, which means this can't be 4 or 8, it's 9. This 8 and 9 here eliminates 8 and 9 here, so it's 4. So this can't be 4, it's 1, that's 4, this is 8. 2 eliminates 2 here, so it's 1, and that's 2. This has to be 2 here, and it cannot be gray because we already have a 2 in the gray, so this is not gray. So it's light. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 lights. So therefore we know this is boundary here, this is boundary here, and this must be boundary here. So this is not green, this is medium, this is not light, it's green, and this last digit is a 7. And that's how you solve it. Pretty cool, actually. This was a very interesting rule set here. Particularly the Pairrows was very interesting. In that it did limit where things could be, right? I almost got stuck in this part right here, where basically I thought the green had to go here and then the red had to be in this area. But I did realize then that this could not be yellow, so because the pink had to go that way. So just typical chaos construction stuff sometimes. Sometimes you'll forget things about that, and you just have to remember where things are hard forced, right? So very interesting. Also, the quad circles was definitely very handy in restricting things. Also, oh, I guess yeah. I could have once I found out this had to be light, this had to be green, obviously. But I still was able to deduce it correctly, right? Because we don't have a quad circle there. That's the reason why that couldn't be light. So we could have deduced that earlier, I guess, but we still came to that conclusion. Interesting. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.